Alright, in this video I'm going to finish the graphing review. So on number 13 it says use the given information to write the slope-intercept equation for each line. So first of all, when I see slope-intercept equation, I know that's the y equals mx plus b. Let me go ahead and put that up here. However, that being said, we don't start with that. We actually start with the point slope formula, which is this one here. And so first of all, this is the point slope form of a line. In order to use it, I need a point and a slope, and we have both. So all we need to do is plug in the numbers here, and then once we've done that, because we need to put our final answer in slope-intercept form, we'll solve for y. So let's go ahead and get started. Our point, in this case, our given point, our x1, y1, is the point negative 2, 4. So it's going to be y minus y sub 1, which is 4, equals the slope, which is negative 3, times x minus, let's see, x sub 1 is negative 2. Notice we're subtracting a negative number there, so be careful. This is going to be y minus 4 equals negative 3 times the quantity x plus 2. Now sometimes students will distribute right at this step here, but I recommend that you don't do that. Often students make mistakes when they skip that step. So I'm going to go ahead and change that to plus 2, and now I'm ready to distribute. So you'll get negative 3x minus 6 on the right side. And the only thing left to do is to add 4 to both sides. And so we get y equals negative 3x minus 2. Alright, so if you want, you could try doing problem B and then watch the video. It's going to be just like the other one, or very similar. Alright, so first of all, we write the point slope form. We need a point and a slope to use it, which is what we have. So let's plug in our numbers. Our given point here is 5, negative 3, which we call x sub 1, y sub 1. And so when we plug those numbers in, you should get y minus negative 3 is equal to 2/5 times x minus 5. And so again, I'm going to take care of that minus the negative 3 there and make that a plus 3. On the right side, we might as well go ahead and distribute it. 2/5 times x is 2/5 x. And then we've got to multiply 2/5 times 5. Let's go ahead and write that as 5 over 1. And really, you could just multiply across. You'd get 10 over 5. Right, 2 times 5 over 5 times 1. 10 over 5, you get 2. Or you could just cancel these 5s, and you're left with 2 over 1, which is 2. So our slope is 2. Notice we are going to get a negative here. It's 2/5 times a minus 5. So this is minus 2. And then again, we need to subtract 3 on both sides because we're trying to get y by itself. And so we get y equals 2/5 x minus 5. Now number 14 is really the same kind of problem. It's asking us to write an equation. And so we know if we have to write an equation, we're going to need point slope form. And again, what do I need to use this? Well, it's called point slope form for a reason. I need a point and a slope. And notice we have 2 points more than we need, which doesn't really matter, but we don't have the slope. But now think back to one of our other formulas. If we're given 2 points, we can find the slope of the line. So we're going to actually use the slope formula here. And let's label the points. So it's going to be y sub 2, which is negative 11, minus y sub 1, which is 9. And in the denominator, it'll be x sub 2 minus x sub 1. So 2 minus negative 3. So again, notice you're subtracting a negative. Watch your signs here. So we're going to get negative 20 in the numerator, and then that becomes 2 plus a positive 3, and that's where I got the 5. And so we get a slope of negative 4. So now it's decision time. we needed a point and a slope to use the point-slope form. Now we have the slope. Now we just need to pick one of those points. So I'm going to go ahead and let it be negative 3, 9. But it really doesn't matter which one we choose. So basically, in this new formula, or the formula we're now using, x sub 1 is negative 3 and y sub 1 is 9. So let's go ahead and plug the numbers in here. It'll be y minus 9 equals negative 4 times x minus negative 3. And again, let's clean up that x minus negative 3 there. Make that an x plus 3. And now I can distribute. On the right side, we get negative 4x minus 12. Right? Negative 4 times 3 is negative 12. And then finally, we need to add 9 to both sides. And we get y equals negative 4x minus 3, which is what we call the slope-intercept form. That's the y equals mx plus b form. So I just want to point out, I kind of like this problem because first of all, we had to use the slope formula. And then when we write an equation of a line, we use the point-slope formula. And then finally, I gave my answer in slope-intercept form. And actually, because I said write the equation of the line, I didn't really tell you which form. You really could have stopped way back here somewhere, because we did write an equation. But again, we normally like, that's not really a nice form of an equation. We usually like the slope-intercept form as a final answer. So I didn't ask for it here, but that would be the preferred method, or the preferred form. All right, let's go ahead and move on to number 15. So on number 15, we're supposed to write an equation for each of these graphs. Well, on A, really there's a couple approaches I could use here. If I have to write an equation, I know that I can use the point-slope form. So we can find one point on this graph, a point like 0, negative 2. And we could also find the slope of this line. And so we could go ahead and use that formula, and there'd be nothing wrong if you did that. The thing is, we actually know the y-intercept here, 0, negative 2. So think about this. We have a slope-intercept form too, and we know we can find the slope, and we also know the y-intercept. And so really, we could just plug those into this slope-intercept form. Again, m is for slope, and the b there is my y-intercept. So notice there's the y-intercept, so b here is going to be negative 2. And the slope, well, let's find another point. So to get from the first point on the left there to the one on the right, we have to rise 3. So I'm using rise over run to find slope here. So I rose 3, so that's positive 3. And then I'm going to run 2, so that's 2. And so the slope is 3/2. So we can just plug in the slope and the y-intercept here, and we're going to be done. So again, you could certainly use the point-slope form, but in this case, I think I would use the slope-intercept form. But either way would be fine. All right, let's look at B. B is one of our special cases, and we know a vertical line has an equation of x equals some number. And so here you can see that any point on this line is going to have an x value of 3. So x equals 3 is the equation of our line. Also, be careful on the test because sometimes students tell me the slope of the line instead of writing the equation. So you have to make sure you follow the directions so that you answer appropriately. All right, so 16 through 20 were our review problems for the test we're taking. And so let's look at number 16. So first of all, there's a shell where I'm going to basically write the same expression, but wherever you saw an x now, there's parentheses. And now we know what x is, and so we're going to plug in negative 2. So basically what we're saying here is we can evaluate or give a number for this expression if you tell us what x is. So we have an x, we're plugging it in, and now we just use our order of operations to simplify this. So we're going to square first. We'll get negative 3 times 4. Minus 2 times negative 2, that's going to be actually I'll rewrite that one. So now let's do our multiplications. Notice we have a couple multiplications, a subtraction, and addition. Always add or subtract last. So let's multiply next. We're going to get negative 12 minus, actually that's going to become a plus 4. It's really minus negative 4, because if you, you're going to subtract 2 times negative 2. But the other way to think of it is you could be multiplying negative 2 times negative 2. So this is a plus 4 and then a plus 5, and when you add those you get negative 3. Now it doesn't make a difference so much here, but remember with additions and subtractions always work left to right, because sometimes it will make a difference. In this case it wouldn't if you added the 4 and the 5 first, but it's not always that way. Let's look at number 17. Again, the safe bet is to work left to right when you have things that are equal priority. Addition and subtraction are equal priority. Alright, let's look at number 17. So let's make a shell, and let's plug in our x and y. And so 5 times negative 3, that's going to be negative 15, and minus, and we can multiply 2 times negative 3 times 4. We'll get negative 15 minus 2 times negative 3 is negative 6 times 4, which is negative 24. So we're going to end up with negative 15 plus 24. Again, you could look at what's here and multiply negative 2 times negative 3, which is 6, times 4, which is 24, and write that as plus 24. So I'm using the order of operations, but either of these ways will get you that answer. So we're going to end up with 9. Alright, let's move on to our last 3 problems here. Now on number 7, you're going to solve and then write your answer using interval notation. So let's go ahead and solve this. We're going to need to simplify the right side. Notice I just distributed here. And so we get 10x minus 20. Now notice we're not done simplifying. We could actually combine the negative 20 and the 12, and that gives us negative 8. So really I'm just using CSI here. I didn't have any fractions to worry about. I simplified everything that I could. Now I need to get x on one side only. That's what the I is for. Isolate x on one side. So we need to, let's get rid of that 10x. With inequalities, I like to keep my x on the left. So let's subtract 10x on both sides. And we'll get negative 3x minus 2 is less than negative 8. Let's go ahead and add 2 to both sides. We get negative 3x is less than negative 6. Now notice we're going to have to divide by negative here, so we'll be reversing the symbol. So that's going to switch. This becomes x is greater than 2. So sometimes it's helpful to graph before you put this in interval notation. X is greater than 2. We're going to shade everything to the right of 2. Notice we're using parentheses because 2 is not part of our set of numbers. X is greater than 2 represents the numbers that are bigger than 2 and doesn't include 2. So finally, in interval notation, that's 2 to infinity. Alright, on number 20, let's see. First of all, we're going to have to find the LCD, which in this case is 24. Remember, we start with the biggest number, which is the 8, the biggest number in the denominator. 8's not divisible by 6, so let's try the next multiple of 8. 16 is not divisible by 6. Finally, we get to 24, which is divisible by the 4 and the 6. And so 24 is a multiple of 4, 6, and 8. That's going to be our LCD. So we'll multiply each of the terms by 24. So let's see, 24 over 4 is 6, times 3x, we get 18x. 2 times 24, we're going to get minus 48 there. 24 divided 6 is 4. You're left with 4 times x, or 4x. 24 divided 8 is 3. And we're left with 3 times 3, which is going to be 9. It'll be plus 9. So notice we need to get x on one side only. So we'll subtract 4x on both sides. And we get 4x minus 48 is 9. Let's add 48 to each side. We'll get 14x equals 57. Not the best of numbers. It looks like we're not going to have a real nice answer here. Divide 14 by 14 on each side, and you get 57 over 14. And that doesn't reduce. All right, let's move on to number 20. So here our LCD is 12. So we'll multiply each side by 12. And 12 divided 3 is 4. Now be careful here. You've got to multiply that 4 times the numerator, x minus 2. We're going to have to distribute here. On the other side, similar thing happens. 12 divided 4 is 3. And again, we're going to have to distribute the 3 times x plus 1. So I like to do this in 2 steps. Now let's go ahead and do the distributing. And we end up with 4x minus 8 equals 3x plus 3. We need x on one side only, so I'll subtract 3x on both sides. And now we're down to a one-step equation. We'll add 8 to both sides. And so we're going to get 11. All right, and that is the end of the review.